Okay. Hey, Jonathan Perez, number 2. What'd you get there? Yes, your answer is 31. Well done. Did anybody not get that and not know what they did wrong? So you just need me to walk through it? Okay. When we do the order of operations, I'm going to erase this 31 momentarily to give us a little room. When we do the order of operations, P, parentheses, is the first thing you have to think about. When we work these parentheses, and there's more than one of them, we have to work from the innermost groupings outward. So the innermost grouping symbol in the problem is that guy there. That's what I have to take care of first. So you do 6 minus 3 to kick off this problem. 6 minus 3, that's 3. So we have to take 2 times 3 in that grouping symbol also. Okay. Next, I see I have some operations to do in these brackets here. I have 13 minus 2 times 3. Well, in those grouping symbols, we have to keep in mind that we still have to apply the order of operations. So now, as far as this line is concerned, you have to decide, do I multiply or do I subtract first? And honestly, you're going to multiply first. So now, in this particular set of groupings, we have 13 minus 6. 13 minus 6 is 7. So what we're actually doing now is 3 plus 28, and that does give us Jonathan's answer of 31. Does that help you out? For those of you that had trouble? Okay. Spinny Wheel of Doom. Talk about number 3. It goes to Megan S. Yes. Wait a second. I have a Megan S in the last period, not in this period. Helene. You are correct. Anybody not get 88? Not know what they did wrong? You're good? Good job. All right, number 4 goes to, this one was a little bit trickier. Nicolette. It is 24. Good job. They may not get 24. Do you need me to walk through it there, Ben? Okay, so we're doing Please Excuse My Dear Aunt Sally. So we're going to take care of multiplications and divisions in the order that we see them. So I'm going to bring down my 14. 6 times 2 is 12. 8 divided by 4 is 2. And now I can just work these in the order that I see them. 14 plus 12 is 26. 26 take away 2 is 24. So that's that guy there. Ooh, what's up? You sure can. You okay? Oh dear. Sounds like that time of year, huh? Hey, John K. You got 2? That's right. Very good. They may not get 2. You need me to walk through it? We're good on that one? Good. Usually when you have multiple grouping symbols and then you throw in some division in there, that one gets a little dodgy. So that was good. And the last one. Lauren. And that's what I got also. 38 is the correct answer. Questions about that? We're good? All right. So yeah, nice job on the order of operations. If you're wondering, Mrs. Lucas, why do I need the order of operations? Well, just a little preview of what we're doing in class today. I have 2 goals to achieve with you today. The first goal is to define a couple of terms with you related to a function, and we're going to use that definition to decide is this thing a function or is it not. So we're going to decide what is a function and what isn't. But we did the order of operations because ultimately we're going to use the property of substitution to plug some numbers in for x, get some numbers back out for y, and write ordered pairs. So we're going to use the order of operation to establish solutions for a graph. So with that, let's get started. Our first mission for today, our first goal, if you will, is to decide, is something a function or is it not? So you can go ahead and take a moment to copy down those definitions. Function, I think this definition applies in 3 parts. It is a relationship between x and y, or it's described as a relation for which each value of the domain is paired with exactly one value of the range. Forgive the shouty caps. A relation where each value of the domain is paired with exactly one value of the range. Domain, just to remind you about that definition a little bit, domain is just possible values of x. Range is just possible values of y. Domain, you could also say, is fancy talk for possible values of your control variable or your independent variable. Range is possible values of y or your dependent variable. And there's 2 ways to look at domain. You could look at it as x values in a t-chart, or you could look at it as the space on the x-axis that a graph takes up. So what you're going to see here off to the side is a t-chart that models this graph. So for instance, when you look at this t-chart here, you might see the ordered pair 1, 2 hiding in there. To plot that point, we go over 1 space and up 2 spaces on the graph. It gives me that point right there. So this chart, this t-chart or table of values, and this graph are actually the same relation. Furthermore, we're going to use both of these things to decide what domain and range is, and then also to decide if this thing in our example box here is a function. Domain and range is super easy to figure out when you look at a table of values. If we've come to understand that the domain is possible values of x, all of the items listed under x are the values in our domain. So the domain of this particular function is just x equals 1, 2, 3, and 4. Also, do you see how this is the space that the graph takes up on the x-axis? You know, I see points at x equals 1, a point at x equals 2, a point at x equals 3, and a point at x equals 4. So that's the domain of that curve. The range, also super easy to find. We've come to understand range as our possible values of y. So if you need to identify your range by looking at a t-chart, it's basically just your entire right-hand column. So that's going to be your range. Depending on the teacher that you had last year and the book that you're looking at this year, some books use f of x to denote the range. Some just denote range with y. I use them interchangeably. They're synonyms. F of x and y are the same thing. It's just function notations versus y equals notation. So we see that the domain is all those x values there, and the range is all those y values listed there. If you look at the graph, this graph confirms our range from the t-chart. We have y values at 2, 4, 6, and 8. So the graph and the table of values actually match up. I just wanted to remind you about something. The definition of a function actually helps us determine if something is a function or not. When we look at a table of values, if you want to decide if your table of values gives you a function, you have to look at the domain column. The trick, if you look at the domain column or the column for x, none of those x values are allowed to repeat. Here's how that works. If you take a look, for instance, on our example here, see the x value of 1? It only occurs one time. That's because the input of 1 gives you exactly 1 output of 2. If I had another occurrence of 1 down here, well, that's the input of 1 giving you more than 1 output. But by definition, you have to have exactly 1 output for any input that you get. So for instance, 2, just to go do it again, the input of 2 is mapped onto only 1 output. It occurs 1 time as a domain value. So because I had 1 input, that input of 2 mapped onto exactly 1 output, 4, so far it's looking like a function. And I see that 3 is mapped onto 1 output and 4 is mapped onto 1 output, so this is indeed a function. Let's say you're not good and you can never remember that, like you get to your test or your quiz or your homework and you're like, holy cow, is it more than 1x? Can't repeat, or is it y? Like, how does this even work? Well, if you're a person who doesn't necessarily remember definitions in math class very well, you could always draw a picture or graph the points that are there and then run something called the vertical line test. I'm going to say that again, the vertical line test. Who remembers that from last year? A couple of you do. Oh, very good, very good. Can anybody tell me about it? Go ahead, John. Yeah, very good. So if you'll see here, you know, if you were buying what I was selling earlier, that this table of values is just this on the coordinate plane, we could just do the vertical line test. So just do it with me now if you could. We're going to draw some vertical lines through our graph. And as I draw these vertical lines, I see what John was telling me happened. I'm a happy girl. Happy, happy, because every time I drew one of these vertical lines, I only hit 1 time. That makes me very happy. That makes this particular relation a function. So that is indeed a function. Questions about that? Okay, let's do a couple more examples together, and then you're going to go ahead and give it a try. In example 1, and you're going to see some of these problems really similar to the ones on your homework tonight. Your homework starts off by just yes or no, is it a function or not? And you're given a couple tables of values. In example 1, we're asked to consider each table. Determine the domain and the range values. So remember, domain is possible values of x, and your range values are possible values of y. Next, we're supposed to decide if the displayed relation is indeed a function. So if we take a look at part A, remember your domain is your possible values of x. So right away, my domain is right above that column there, like that whole column of x. Those are all of my possible values of x, and that is my domain. It's pretty easy to write domain because you're basically just copying all of the values that occur under the column for x. In this class, to write domain, we use a little bit of set notation, and I described that bracket I just drew. I'll draw another one off to the side. That bracket I just drew, I call it the Jay Leno bracket. You got an eyeball, there's his nose, and then he has like a super mutantly large chin. So that's my little Jay Leno bracket there. But yeah, you're going to go ahead and put it in a bracket, and you're going to just list out your values from smallest to largest. So my smallest x value is 10, then it goes to 15, then it goes to 27, then it goes to 29, and my last x value there is 36. And then you lump it together there, close that bracket. We have that set, the domain is that set of numbers. To identify the range for this particular graph, all you're going to do there is list out your possible values of y, because that is our definition for range. So I'm going to write y equals, open up a little bracket here, and I again go from smallest to largest. And these are actually in order, so that helps. My range values are -5, 1, 6, 7, and 8. Notice that no value in the domain repeats itself. Each value of the domain is paired onto exactly 1 output. Do you see that? Nodding. So the 10 doesn't repeat itself. The 10 is mapped onto one output. The 15 only occurs one time. It's paired up with 1. 27 occurs one time. It's just paired up with 6. 29 only occurs one time. It's paired up with 7. 36 only occurs one time, and it is paired up with 8. Because I get that relationship, this is a function. It would pass. So if you're a person who can't remember the definition necessarily and just look at the table and decide if the x values repeat, you could always draw a picture. This would pass the vertical line test. Now let's do it again. In part B, again, you're asked to identify the domain, which is your possible values of x, and then your range, which is your possible values of y. So I go ahead and I list out my domain values, possible values of x, and I always go from smallest to largest. If a domain value repeats, you need only list it one time. So I see that a number repeats up there. I'm only going to write it down once. I always go from smallest to largest. So my smallest domain value is at 0. Then I go from 2 to 4 to 6. My range values are my possible values of y. We always list those out in order as well, from smallest to largest. I see my smallest range value is 0. Then it goes 2, 4, 6, and 8. What I see when I decide if this is a function or not, the thing that catches my eye is that I have the input of 2 mapped onto initially an output of 2, but then I have it listed again, an input of 2 mapped onto a different output of 6. That input 2 is mapped onto 2 different outputs. That is not a function. Each input must be mapped onto exactly one output, so that's not a function. Let's say you can't remember that definition. Looking for like things to repeat in the x column doesn't quite work for you. Remember that all we're actually doing is a different version of the vertical line test. So you could always draw a picture. You know what goes on the smartboard goes in your notes. So let's say you're a person who does a little bit more spatial reasoning. That's your thing. I could go ahead and plot these 2 points that I highlighted in yellow. Watch what happens if I plot those. So over 1, 2, up 1, 2, 3, 4, 5, 6. So if I go over 2 and up 2 to plot the first yellow point, and over 2 and up 6 to plot that second yellow point there, if I plot those 2 points, do you see what kind of line I make if I connect them? That's a vertical line right there. So that fails the vertical line test for being a function. This thing can definitely not, based on both tests. This is not a function, fails the definition. Okay, question about why that's no? All right, now it's your turn. You get to try. I'm going to go ahead and plot this real quick. So, first of all, I need the domain. This person's going to tell me the domain. It goes to Eddie. Good. Brick. Very good. You don't even need a set around that. You don't need a bracket around it. It's just y equals 6. Okay, and then is it a function? Doesn't look like really. I didn't see anybody who sort of fell for this yet anyways. Alex. It is. All right, questions about that? Nice job. We have one more example and then we're done. I did give you order of operations problems in the warm-up today. That was for this guy. What we're going to go ahead and do is begin to identify solution points for a function. All you're going to do is you're going to take the value of x, plug it into the function, and produce a point for me, an ordered pair. So let's take a look at part A right here. We have y equals 5x minus 2 for when x equals 3. So we use our property of substitution to let x equal 3 in this particular equation. So what we get is y equals 5 times 3 minus 2. In other words, we have 15 minus 2. 15 minus 2, 13. So we have the point 3 comma 13 as a point on this linear equation. For part B, we again use our property of substitution. Careful when you're plugging in a negative. I'm going to put parentheses around it to kind of keep it safe, especially if you're a person who leans on your calculator. And then wherever I see an x, I'm going to fill in that negative 7. What I see here is I have basically 49 take away 4. 49 take away 4 is 45. So this particular parabola contains the point. The x value is negative 7, and the y value is 45. It's in this way that functions are like machines. You can put a number in and get a number out. What's up? I quantify negative values. So in this case, I used parentheses because I was subbing in a negative. It says x squared. So you take whatever x is and square it. In this case, x was negative 7. So you have to take negative 7 times itself. That's what it means to square something. So we take negative 7 times negative 7. That's why we got a positive 49. Does that make sense? Now, I use caution when I say yes to an always question because, Jonathan, I gotta ask you this. What if I had negative, like, x squared, you know? Yeah, so if I change this equation ever so slightly and I put the negative here, this would then be a negative 49. Make sense? So when you say it is always positive, I mean, you know, I'm not a fan of pronouns. You got to kind of still exercise some caution. Okay? Any other questions? All right, part C. We have y equals 3/4 x. My purpose in doing this problem with you is I just wanted to review how you work with the fractions a little bit. So for part C, again, we're going to use our property of substitution to plug x, an x value of negative 2, into the function. So instead of writing 3/4 times x, I'm going to write 3/4 times negative 2, which is like negative 2 over 1. Remember, when you multiply and divide fractions, you don't need a common denominator. You can actually just multiply straight across. So when I do this multiplication, what I'm going to get, 3 times negative 2 is negative 6. 4 times 1 is 4. You have to reduce that. I saw in a couple of the quizzes people were forgetting to reduce. So watch those directions. It's always going to prompt you to make sure your answers are in lowest terms. So this reduces to 3 over 2. So what we actually get is an x value of negative 2 outputting negative 1.5. Probably saying, whoa, Mrs. Lucas, why did you just turn that into a decimal? Well, thinking ahead a little bit, we're going to be graphing. It's a lot easier to graph or plot decimals as opposed to fractions. You know, think about it. Let's say I said, hey, plot 16 over 3. That was me, sorry. 16 over 3, that's like 5 1/3. You know, what would you rather graph? So it can be really helpful to just graph the decimals. Okay. Part D, we're going to go ahead and plug 5 in for x there. 3 times 5 squared plus 5, more or less what I get there. 5 squared is 25 times 3 is 75 plus 5. Oh my goodness, if we had to plot that, we would definitely want to scale our graph. We'll talk about that more tomorrow. We have the point 5, comma 80. That's a really big point. You wouldn't probably want to tick off by 1s if you were asked to graph that. Tick off by like 5s or 10s even. Okay, questions about that? That is our lesson. I taught you 2 things today. How to tell the difference between what is a function and what isn't, and how to find points or solutions for a graph. We're going to use this idea, or these ideas rather, more tomorrow. Your assignment for tonight, you grabbed it when you walked in. Your conclusion activity for today is to start on those first couple problems. You have 1 to 33 odd on notebook paper. As you get towards the bottom of the paper, you'll see that it says, hey, let the domain be -3, 0, and 3. Well, all they're telling you to do is to take your control variable, plug in 3, plug in 0, and then plug in -3 and give me those outputs. Basically, you're giving me 3 ordered pairs for those answers, giving me the range value that corresponds. So if you're wondering what that means, that is what that means. You'll see it when you get there. Okay, and yeah, so you guys can go ahead and take care of that.